Today I want to look at the intersections between lines and curves. Now, to find the intersection where the line 2x minus 4 intersects with the parabola y equals x squared plus 3x minus 6. To do this we need to solve these simultaneously. So if I call that one equation 1 and that one equation 2, what we're going to do is substitute equation 1 into equation 2. So we'll end up with 2x minus 4 equals x squared plus 3x minus 6. Now this is going to be a quadratic, which makes sense because if we've got a curve like a parabola, the line's likely to cross it twice, therefore we'd be looking for two solutions. And with all quadratics, to solve it we need to get it equal to 0 first of all. So if we move the 2x minus 4 over, we end up with x squared, 3x minus 2x is x, and minus 6 plus 4 is minus 2 equals 0. Now we can solve this. We should be able to factorize this one. So that's x. Now, because that's negative, the signs are different, so we're going to have 1 plus and 1 minus. Because the x term is positive, it means the larger number is positive. So it's going to be x plus 2, x minus 1. So x plus 2 equals 0. So x equals negative 2. Or x minus 1 equals 0. So x equals 1. This, however, only gives us the x coordinate, so we need to find the y coordinate. To do that, we'll substitute into equation 1. Now if x is negative 2, y is going to be 2 times negative 2, which is negative 4 minus 4. So y is going to be negative 8. And if x is 1, then y is going to be 2 times 1, which is 2 minus 4. So y is going to be negative 2. So the 2 points of intersection are going to be negative 2, negative 8, and 1, negative 2. Similarly, to find the point or points of intersection of this line and this curve, what we're going to do is we're going to take equation 1 and we're going to rearrange it. Now, probably the best way to rearrange it is to make it y equals. So, first of all we can say 2y equals 7 minus x. So y is equal to 7 minus x over 2, and we'll call that equation 3. Now what we'll do is we'll substitute 3 into 1. Nope, sorry, I was wrong there. We're going to substitute 3 into equation 2 because we've already used 1. So now instead of y equals, it's going to become 7 minus x over 2 equals negative 2 x squared plus 4x plus 9. Now, I don't know about you, but I don't much like fractions sitting there, so what I'm going to do is I'm going to multiply both sides by 2. So on the left we get 7 minus x. Now on the right we need to multiply every term by 2, so that becomes minus 4 x squared plus 8x plus 18. That's because we're multiplying the side by 2, so every term gets multiplied by 2. Again, we have a quadratic, and as I don't like factorising with negative x squared, so I'm going to get everything on the left. So we'll end up with 4x squared minus x minus 8x is minus 9x. 7 minus 18 is minus 11 equals 0. Now this one doesn't look as if it's going to factorise easily, so we could use the quadratic formula where a is equal to 4, b is equal to negative 9, and c is equal to negative 11. So using the quadratic formula we get x equals minus b, so that becomes 9, plus or minus the square root of negative 9 squared, not forgetting to put the negative 9 in brackets, minus 4 times 4 times negative 11, all over 2 times 4. So simplifying the bracket first, that's x is equal to 9 plus or minus the square root of 81 plus 176 all over 8. Now notice that the minus 4ac becomes a plus because the c is negative, and that simplifies even further to 9 plus or minus root 257 over 8, and if we plug that in we're going to get 9 plus root 257 divided by 8, which is 3.13, or we're going to have 9 minus root 257 divided by 8, which is negative 0.879. Negative 0.879. Now, similarly, we need to find the y values. So if you remember, y was equal to 7 minus x over 2. So for x equals 3.13, y becomes 7 minus 3.13 divided by 2, which is 1.94 or 1.935, and for x equals negative 0.879, y is going to become 7 minus negative 0.879 divided by 2, which is 3.94. So the 2 points of intersection are going to 3.13, 1.935, and negative 0.879, 3.94. And if you look at the graph, this is the two graphs plotted, which you can do on your calculator. You can see that you've got your 2 points. The one there, which is your negative x value, and y was 3.94 or something like that, and your other one there. However, not all graphs will intersect, so you might have a graph, for example, like that, where the line and the parabola don't intersect. Or you might have a graph like that, where the line touches but doesn't cross. That's actually meant to touch. Touches but doesn't cross, so in effect it's a tangent to the graph. Or like the previous examples, you might have a line that crosses twice. How can we tell what we're going to get? Well, we come back to our discriminant, because whenever we substitute in, solve our simultaneous equations by substitution, we end up with a quadratic. And once we've got our quadratic, if b squared minus 4ac is less than 0, we know there are no solutions, no real roots. And that means the line and the curve do not intersect. If when we substituted and got our quadratic, b squared minus 4ac equals 0, that's when we have one repeated root, or one real root, and that means that the line is a tangent to the parabola. It means it touches but doesn't cross. And if we have b squared minus 4ac is greater than 0, then we've got two real roots. That means the line does cross the curve and it intersects at 2 points.